topographical map is one which represents the appearance of the ground. It shows natural features such as mountains, hills, valleys, plains and rivers, and also man-made features such as towns, cities, roads, railways and vertical obstructions, for instance radio masts. Not all charts used in aviation show these features. A radio navigation chart, for instance, is little more than a diagram of the division of airspace. The only natural features shown would be coastlines and occasionally major waterways. Topographical maps are therefore used for visual map reading. Airliners normally use radio aids for navigation, and it is unusual to use map reading on major airline flights. However, there are areas in some emergent nations where navigation aids are sparse, and visual map reading is occasionally still used. It is also an essential skill during the early stages of practical flying training. We will firstly discuss the characteristics of topographical maps. Then consider practical map reading techniques. And finally, look at some of the more common conventional signs used. Before we start, let's see if there's any distinction between the terms map and chart. A map, such as this Ordnance Survey sheet, covers only a small area, but shows large amounts of detail. A chart, such as this one, shows a larger area, but with much less detail. The definitions are loose, and an intermediate scale chart, such as the ones we use for visual navigation, can be referred to as either a map or a chart. In this lesson, the terms can be used interchangeably. Topographical maps have three basic characteristics. They show relief or terrain. They show other features such as waterways, woods, roads and railways. And they have a scale. This is something that you should always be aware of. You should have a rough idea of how far down track you expect to be at a given time. Use of your watch and a knowledge of the scale allows you to look in the right part of the map immediately and not waste time. If an aircraft is to be navigated safely in poor weather, great care must be taken to avoid high ground, either by flying round it or over it at a safe altitude. However, some terrain features can make excellent visual references in good weather. For instance, a set of contours looking like this will look something like this on the ground. In good weather, you will probably be able to see that from 20 miles away. At light aircraft speeds, this means that your navigation problem is taken away for the next 10 minutes. Just aim slightly to the right of the ridge and stop worrying about intermediate map reading. Concentrate on other flight deck management tasks instead. Terrain can be shown in various ways. Contours are lines joining places of the same elevation above mean sea level. Always check whether the elevations are given in feet or meters. On aeronautical maps, the contours are usually filled in with layer tinting. Spot heights show the elevations of prominent peaks. There is also a method of giving elevation information for a rectangular area based on latitude and longitude. For most topographical charts, this is a rectangle based on half a degree of latitude by half a degree of longitude, but it can be a whole degree, so check each chart. These can be either maximum elevation figures, known as MEFs, or minimum safe altitudes, MSAs. They are not the same thing, and the difference can be crucial, so we will take a little time to explain it. Within each rectangle, usually of 30 minutes of latitude by 30 minutes of longitude, two separate elevations are identified. The highest natural feature, mountain, hill or ridge, and the highest man-made obstacle, such as a TV mast. It is a legal requirement that any man-made structure with a height of 300 feet or more must be reported to the National Aviation Authority, the CAA in the United Kingdom. Therefore, there is no need to add any further safety allowance. The exact height is known. However, there may be unknown structures just less than 300 feet tall at the top of natural features. We therefore add a 300 feet safety margin. As an example, assume that a rectangle includes both a hill of elevation 1437 feet and a TV mast of elevation 1687 feet. The elevation of the TV mast is known. It's 1687 feet. But if we add a 300 feet safety margin to the hill, in case of unknown obstructions, this gives us a figure of 1737 feet. We now round up to the next 100 to make it 1800 feet. What happens now depends on whether the map shows maximum elevation figures or minimum safety altitudes. The figure we have arrived at is the maximum elevation figure. UK CAA charts show MEFs. This is the actual elevation of the feature. There is no additional safety margin. It is up to the pilot to add his own safety margin, usually 1,000 feet. American ONC and TPC charts also show MEFs. However, AIRAD and Jeppesen charts add a safety margin of 1,000 feet where the terrain is 5,000 feet or lower, and 2,000 feet where the highest points are over 5,000 feet. So let's summarize, because this point is important. UK CAA charts and American TPC and ONC charts show MEFs. These are the highest feature in each rectangle, and there is no 1,000 or 2,000 feet safety margin for altimeter errors and downdrafts. Do not treat these as safety altitudes. Jeppesen and AIRAD charts show MSAs, which do include this safety margin. Never treat an MEF as an MSA, or you may find yourself in a cloud flying at the same height as the top of a hill or mast.